and now I have 1.01. So I've adjusted this to the positive side by 1%. Now, let's take a smaller sample size. Let's take 50 and over 49. So 50 divided by 49 is going to be equal to 1.2 or 0.2, which is 2%. So it increased this sample size by 2%. So I'm making adjustments. So the smaller the sample size, the larger the adjustment. That makes it more like a population. So now let's go down to 5. So I've got 5 over 4, and that's going to be equal to like 25%, I believe. So 5 divided by 4 is going to be, 1.25. So what that did is it made an adjustment of 25%. And that's what we're doing with our degrees of freedom. We're making adjustments based on our size of our sample. That's why it's so important. So that's kind of a pretty good example of population and sample standard deviation and variance. It's basically the same, other than the sample is going to use some adjustments. Because we're not dealing with the entire population, we have to make some adjustments, and that adjustment is called degrees of freedom. So now, if we're not making any adjustments and we're dealing with what we call a normal distribution of scores, where we're going to have the mean, the mode, and the median all falling at the middle, and we have what's called a mean of 0 and our standard deviations of 1, we call this a Z distribution. Now, this is a Z distribution here. As we can see that we've got our mean is directly in the middle. This is normal, and we've got 1 standard deviation, 2 standard deviations, and 3. So in this particular example is I have a mean that's equal to 0, and I've got a standard deviation that's equal to 1. This is the same as the population, which is going to be mu is equal to 0, and sigma is going to be equal to 1. And I've got 1 standard deviation. And the empirical rule on a normal distribution is that plus and minus 1 standard deviation from the mean, which means plus and minus 1 standard deviation from the mean is equal to 68%. That means that 68% of all the observations are going to be found within plus and minus 1 standard deviation of the mean. So if we go 2 standard deviations from the mean, and if I say plus and minus 2 standard deviations from the mean, which is 2 plus 2 and minus 2 standard deviations from the mean, is going to account for 95% of all the variance in this particular distribution.
And that's exactly what I was going to say.